At this point, we are ready to start creating programs. We're going to go to Cam, Profile, New. In this case, we're going to use a Z-level rough cutting with multiple tools. We are going to call the program Rough 01. We are going to select a generic profile that we are going to reference for our machine tool settings. We're going to go to our tooling database to pick a cutter. In this case, we're going to use a 12 millimeter bull nose. So we're going to select that cutter, and we're going to select our rough settings from our parameter list. Click Create. With automatically add to calculation process, you will see this automatically show up at the top of our list in our calculation process. You will notice some functions have automatically been selected. Our surface to machine has already been selected because we put our part on layer 1. If we go to layer 15, we will notice that our cutting range has already been selected because it was set on layer 15. Next, we are going to go through the cutting parameters of this toolpath. This is a roughing toolpath designed to remove material through open areas of parts. Some of the functions we have in here are different path types, our start heights, end heights, arc processing, whether or not we want to add arcs into the corners, less of a step down for lower lying areas, adding extra passes for flats. We're going to shut this off because there are no flats on this part. Traveling type, one-way, bidirectional, stock. Approach and escape control is found in here. Precision is dealt with on this page, and this is your tool settings. A 12 millimeter tool with a 2 millimeter radius, your RPM, feed rate, step over and step down are all dealt with right in here. You notice there are variables D, R, F, E, and Z. These are all referenced, and any page that is using a yellow field is pulling the variable from that page to be used in calculation. Next, we will start the calculation of this toolpath by hitting Start Processing. You will notice that first, the stock model is converting. When it turns blue, it is in the process of converting into a usable stock model. Once it turns green, it has now been converted into the stock model we are going to start our project with. Now that our toolpath has finished calculating, we can double click on the toolpath to see what the toolpath looks like. Next, we would like to optimize the toolpath by clicking the Optimize All function. You will notice it says Not Processed here. And again, by hitting play, this will allow us to optimize the toolpath. When we refer to optimizing the toolpath, this is your collision checking portion of CAM tool. Now that we have optimized our toolpath, we can see that it has come back with a warning. By right-clicking on this warning and going to Show Optimization Error, you will see a warning pop up telling us our holder is interfering. The interference length is 18.5 millimeters. The protruding length must be more than 47.5 millimeters. Now that we know how long our tool needs to be, we can go into our optimization conditions sheet and change our protruding length to longer than 47.5 mil. In this case, we will make it 50. By hitting Tab, it will show your tool length, and hit OK. You will notice this says changed on here, which means we can recalculate it to see if this will clear after our change. If we would like to clear the program off of the screen, we can clear CL with this checkmark button to get rid of showing the program. Now that the program is done re-optimizing, we can see that it says normal and is green, so we know we are good to move on to the next program.